Thank you so much, Anton, for the invitation, and congratulations to the whole ECOVAL project consortium and the results obtained. Right, so I'm here to explain about sludge management at the AGBAR group that the Aqua is part of, and here we have some general figures of the group to give the context on water with the main figures. I'm not going to deal with all of them, but here we have the amounts of distributed water, which is about 27% of the total water registered and not registered in the Spanish state, and around 25% of treated water, nearly 1,000 cubic hectometers per year, with around 10 to 12% of water that we're regenerating in our facilities. So here we have the El Prat regenerative station with nearly half of all regenerated water, and one of the drivers that we will not mention here in regenerated water. That's a big part of the group for circular economy. And here we have the valorized waste in the urban cycle, around 73%, and then we look at the specific figures for sludge, which are a bit higher, but that shows the regional presence in all the Spanish state. So my presentation is entitled An AGBAR Vision. That's our vision in the group, although we're of course open to any change and any evolution in the future. And we're going to speak about agricultural recovery, which is quite usual historically, as well as pollutants, which are quite important, and there are some pressure elements regarding metals, and of course now with organic pollutants. And here we have the main valorization figures in the group. We all come from different areas, so we have some general slides here. If you work on water, you all know what the sludge line at a water treatment plant is. But here we have different processes that lead to a product with different ways to get valorized. We have agricultural valorization after composting or drying for agricultural use, energy valorization, and Ricardo was mentioning down the pyramid we have the final valorization, quite small, but it does exist if the criteria are met, and that's the landfill valorization. And here we have different generic concentrations of sludge we produce. So we have thickened sludge that we concentrate gradually, and eventually most of our sludge has between 15 and 30% of dryness, which is a sludge we valorize out of our facilities. In the case of drying sludge, the percentage of dryness is quite high, but currently in our group we do not do thermal drying, but other international Veolia plants do it. And after thermal drying, they end up with a product with high concentrations of dry matter. So this will be the general composition of the sewage sludge of the dry part. And as you can see, these are average general values. And here we can see what we have in the sewage sludge. We have organic matter, and then non-organic components such as calcium and magnesium. Then we have also fertilizer elements such as nitrogen, phosphorus, and potassium. Then we have trace elements such as organic and non-organic pollutants that be kind of troublesome but improve valorization. As exploiters of treatment plants, we take into
las diferentes contribuciones de lo que tiene el tratamiento de un metro cúbico de agua en nuestras instalaciones. Son valores.
And then we have the treatment of a cubic meter of water in our facilities. These are generic values from 2019 to 2020. You might say, well, maybe the cost of energy went up this year. We all know what happened last year. And here we have the contribution of managing sewage sludge and pre-treatment waste, which is about 10% in Spain. Of course, it depends on how the community is doing, but here we see the weight as exploiters and what represents an exploitation cost for us. And as a context, I should say that in other European countries, the cost distribution is quite similar, as set for other elements. The price of energy is not the same here as in Italy or France, or the price of chemicals, but we should take into account that sludge that has transport and treatment costs that are a bit higher. So here we have the context. These are general figures to have the global picture, and in Spain we have these figures. About 85% of sewage sludge end up in agricultural production, about 15%, mainly in the Basque Country, go to energy valorization, and we have managed to reduce another percentage. But unlike Javier and Ricardo, who have a much more variable evolution throughout the years, here the figures have not varied significantly in sewage sludge management in Spain, always with certain differences and deviations. It is important to note that there is great variability in the ways regions manage things. There is a European directive from 1996, a long time ago, but in the last few years we have seen a trend by regions to increase the laws passed for hygiene measures. In Galicia, we were pioneers in 2012, and lately Andalusia has done something in that regard. In December this year, we got a new decree on sustainable nutrition, also giving certain important challenges for the future from January 1st, 2024. Regarding Europe, figures are slightly different. We're not speaking about such a relevant path, but rather that agricultural valorization is still the main path by large, and it represents between 50 and 55% of generated sludge. In the Netherlands and other countries, the burning has a much more important weight, and here energy valorization represents about 30%. And our vision at AGBAR is that there is this agricultural value, and this application, either direct or with composting, has certain positive points. And we have the waste valorization pyramid, and from these macro and micro nutrients and these organic matter contribution, because in Spain in general, our land does not have much in organic matter. Maybe in Galicia it is not so relevant, but in general, in the Spanish state, our land is usually poor in organic matter. We have many areas in the process of desertification, and since organic matter may represent 75% of the sludge, that's quite important. And there's certain disadvantages and challenges. We know about the nitrogen excess and how that should be managed to avoid certain risks of heterophization. And there are several other things regarding heavy metals, pathogens, smells, and even now the sixth part about stationality or seasonality. The sludge generation is quite stable throughout the whole year in the whole country. I mean, a plant could change between the summer and the winter, but in global terms, the production is quite constant. And for crops, that seasonality may be challenging, and production is not always at the same point as the final valorization. So we can not always valorize close to the production point with the carbon footprint that entails.
Obviously, we could also compare this with energy valorization. And here it's true, and this has been explained very well by Javier. He talked about this chart of the pollutants and with this monitoring in all of the incinerators to look at their compliance. And obviously, in agriculture, there are many people concerned about these metals in the soil. And similarly, as Javier has explained, we are concerned about their presence. Some are more volatile than others, some turn into gas, others don't, but they all have a limit on their emissions because those pollutants are indeed still there. And if we talk about the thermal aspect, well, we can recover phosphorus. It's not easy, but this, I mean, if we talk about potassium and nitrogen, if we recover them, they're nutrients. And the thermal technique could mean that we lost out on that potential. So it's important to see the best way we can recover phosphorus. And I think that, well, we're running a little bit late, so I'll push on, but sludge also competes with other fertilizers, secondary fertilizers and agricultural products. I'm not going to go into all of the details. If we talk about the brown container, that could be something we could talk about. We have compost and obviously they have high levels. We have the subject also of the slurry manure, and this is something well known by farmers and is related to pollution, just like with the antibiotics. There are double the amount of antibiotics in slurry compared to human consumption. And however, for human consumption, we have different pollutants. And my thesis director always says that zero and infinite, well, they exist. And if you look at things closely enough, you can see things everywhere. If we talk about pollutants, we could focus here on the risk of these pollutants. There are more and more articles, there are more and more contaminants, and we have more and better analytical methods to be able to detect everything. So we could measure absolutely everything, and we can measure lower and lower quantities, which is something positive. And there are countries where these assessments are forbidden, but this has a bad side, because if you forbid something, if you forbid one particular path, then others become more expensive, and there's no scientific evidence that show risk of using sludge in agriculture. It's more of a kind of, well, taking care with regards to this risk. And the paradigm is Switzerland in 2003. We had the mad cow crisis. And back then, because of that situation, they decided, and since then it's been kept the same, and they forbade the use of sludge for agricultural purposes. And there are obviously many aspects. We could look at them in detail, but they've maintained that situation in Switzerland. And if we talk about COVID-19 in France, well, just very recently, from April till the end of 2020, they also forbade the use of these sludges in agriculture, but they weren't having a good PCR analysis or anything, but they just said to be cautious, they weren't going to allow valorization of slurry from water treatment or treatment plants. So if we talk about risk analysis, there are lots of studies. We have probabilistic studies looking at the different applied doses, the concentration of the pollutants, how they filter through to underground water, and how the plants accumulate them as they grow. Everything has been studied and looked at, the risk of the insects to pass on something or to consume something, and the animals eating the plants or grass, whether they are at risk, and if this could reach humans if we eat products from the earth and where sludge has been used, and all of the risks can be analyzed. And if we talk about traditional pollutant metals and micro pollutants when it comes down to it. What this shows is, well, we don't go into the details, but if we talk about cadmium, this is interesting because the new royal decree actually reduces the limit for cadmium. So cadmium is, well, it makes sense when it comes to risk analysis because it's the one which is closest when we look at human risk. It's closest to overgoing or passing the threshold. And we could talk about the impact in aquifers, underground water, where we've seen the application of sludge. There is a slightly higher risk, but not entirely significant. We need to look at the real measured concentration. Obviously, these are probabilistic studies, and they're much lower when you measure than if you estimate, according to the transfer models. So a whole load of studies have been carried out, and there is no scientific evidence saying that if we use sludge on the land, the plants that grow there represent a risk. There's no significant evidence of this. If we move on to microplastics, we could actually talk about this for a very long time. It's a micropollutant, which is new, complex. We're still learning to measure this, so I shall skip over this one because I've been told that I've only got 2 minutes left. Here, well, just some ideas, because this 1% is of concern, and we have an important part, which is source control, and we have to work on this in order to make sure that these pollutants do not reach the end point in a significant way. And we're talking about the control of waste discharge. This is very exhaustive to make sure that these pollutants don't get into the slurry or sludge. If we talk about agricultural valorisation, here we can see the Spanish territory, and we have this for the north. Here we have the figures regarding production of sludge in the last year. We can say 25-30% of production is from the Barcelona waters, and then we have 15%, which would be Catalonia, Balearic Islands, and the rest of the regional offices, which would have 10%, to give us the total of these 200 kilotons of dry material, which is 25% of total Spain. And if we talk about the destination, and if we talk about sludge and agricultural valorisation, we can see that it's higher than 90%. Here we can't see landfill. It's true that in some years, in some places, it's being sent to landfill. We also have grey composting, which in Catalonia in particular, this is for sludge that has not been digested and have metal problems. They are stabilized, and this is grey composting before it is sent to the landfill. This represented 1% last year of all of the sludge, and this is more or less what we've had in recent years. So there's just this small part of the sludge which would end up in landfill. And I would highlight one thing, which is another internal treatment plant. I think this is interesting, however, because we are promoting sludge platforms to be able to deal with different sludges from different plants in order to produce biogas in a centralized way, and to go from having plants which require external composting to be able to do this directly. I shan't go into the details, the figures for the platform, but this is a concept that we are promoting, and that's what we're including with this internal treatment for the sludge. This is information from the DG for North area and Viacqua, with different figures for this valorisation, agricultural valorisation, which can be direct or indirect. Here it's indirect because of these regulations from 2012. Only the Ourense part, the Ourense treatment plant, which has direct application. So the key takeaways, there's a lot of scientific evidence which shows that eating crops on land in which sludge has been used does not represent any additional risk. And we can see that a non-valorisation in agriculture is a failure for the circular economy. This doesn't mean that everything has to be done locally and regionally, but we can have a mix of alternatives in order to provide overall sustainability to the cycle in terms of value and operations. We have to improve quality and traceability, obviously, focusing on source pollution, and that's key. We're also working to see how to be more sustainable with alternative criteria, looking at traceability, GPSs in all of the trucks, calculating carbon footprint for transport, promoting the green fleet for these sludges. And all of these factors are important when it comes to maintaining this as a priority area of activity in the group. And I'll leave this on the screen for the next session. This is what we have right now, what we had in the past, but well, in the future, we could move towards other forms of valorization for the energy recovery from the sludge.